Welcome to our next lesson in the series of sets, relations and functions. So far we have been dealing with the sets of real numbers and numbers which we were able to represent on one straight line called the number line. This is 0, 1, 2, 3, 4. Minus 1, minus 2, minus 3. But from now on we will be dealing with numbers in pairs like 3, 4, enclose them in brackets, and this is one entity which is called an ordered pair. In this pair, the first number is called abscissa. So whatever number occupies the first place, that will be called abscissa, and the second number, that will be called ordinate. Where do these pair of numbers come from? Actually, we have been operating on sets, and we were able to operate on sets with the operation of intersection, but that will produce another set of real numbers. Union, that will also produce set of another real numbers. The complement of a set, that will also produce another set of real numbers. But now the fourth operation on sets, we will call it product of sets, or more specifically we will call it Cartesian product of sets. Let's take a look at example. If we have a set A which is equal to 1, 2, 3, and we have another set B which is equal to 4, 5, then the Cartesian product of sets A and B will be denoted by A cross B, and this will consist of all ordered pairs in which the first element will come from A and the second element will come from B. So in this case we will have 1, 4, 1, 5, 2, 4, 2, 5, 3, 4, and 3, 5. And this is, now how many elements in this? 1, 2, 3, 4, 5, 6. How many elements were in A? There were 3 elements. And how many elements were in B? 2. 3 multiplied by 2 is equal to 6. So A cross B will contain 6 pairs. If we were to find out B cross A, then first element will come from which set? You're right. The first element will come from B now, because B is on the first place. So this time now the set of ordered pairs that can be formed from B cross A will be 4, 1, 4, 2, 4, 3, and then 5, 1, 5, 2, and 5, 3. This is what is called the Cartesian product of sets. In set builder notation, if we were to define this, we would say that A cross B is a set of all ordered pairs AB, where A comes from A, like A is member of set A, and B comes from set B, that's how we will define. So Cartesian product of sets, in words, if we were to define Cartesian product of sets, can be defined as set of all ordered pairs AB, where A belongs to set A and B belongs to set B. This is the definition of Cartesian product of sets. And now, if these were set of real numbers, how we are going to place them on a graph paper? For this purpose, we do have a system which is known as Cartesian coordinate system. And in Cartesian coordinate system, in Cartesian coordinate system, we draw two lines. One is vertical line and the one is horizontal line. This horizontal line is called x-axis, and this side, right side, is labeled as x. The left side is labeled as x dash. The top side is labeled as y. The lower side of vertical line is labeled as y dash. And the point where these two vertical lines intersect perpendicularly is labeled as origin. And this is called Cartesian plane. If we are to plot the numbers on this, let's say that we want to plot a number 4 and 5. The first element in the pair is called abscissa, and the second is called ordinate. Abscissa can only go left or right depending upon its sign. If abscissa is positive, we always start from origin, and if the abscissa is positive, we will move 4 steps toward right. If it was negative, then we will move 4 steps toward left. So if we want to plot this number 4, 5, we will move 4 steps toward right. 1, 2, 3, 4. And then we look at the ordinate. If the ordinate is positive, we go up. If ordinate is negative, we go down. So in this case, 5 is positive. So 1, 2, 3, 4, and 5. That's where we end up. So remember, first we plot abscissa, then we plot ordinate. Abscissa is 4, 1, 2, 3, 4, and then ordinate is positive 1, 2, 3, 4, 5. That's where we end up. So this is the final destination of point 4, 5. We can name this point as whatever capital letter we might want to use. Let's use the capital letter A. Now let's plot -2, 3 on the same grid. Now abscissa is negative, so we go 1 and 2 toward left, and then 3 is positive, we go 1, 2, 3, and that's where we end up, -2, 3. And let's name this as point B. Now this whole plane is divided as you can see in 4 parts. This positive x, positive y is called first quadrant. The second is called, this is second quadrant, this is third quadrant, this is fourth quadrant. So obviously if you see here, positive x, positive y, both all the numbers in which abscissa and ordinate are positive, they'll go in the first quadrant. If x is negative but y, the ordinate is positive, they will go into the second quadrant. If both are negative, we are going to move left and then we're going to move down. So minus x and minus y, that will go in third quadrant. And if x is positive but y is negative, then this will go into the fourth quadrant. This arrangement of plotting numbers, pairs on the graph paper is called Cartesian coordinate system, and these numbers x and y are called Cartesian coordinates of that pair. What would happen if one of the two sets A and B was a null set? So remember this thing, that if A is equal to 5, null set, doesn't matter whatever B is, A cross B is always going to be a null set. Or if B is equal to null set, doesn't matter whatever A is, A cross B is always going to be null set. What it essentially means is that if one of the two sets is a null set, the answer, the Cartesian product of the sets, is always a null set. Number one. Number two, if we change the order, like if A is not equal to B, if two sets A and B are different, then A cross B is not same as B cross A. And now we are going to discuss the binary relations, or let's say simply relations. Relations of sets from A to B. If we want to find out relations of sets, any subset of the Cartesian product A cross B is called a relation from set A to B. Let's take an example. A is equal to 1, 2 and B is equal to AB. Then what would be A cross B? A cross B would be equal to set of all ordered pairs in which first element will come from A and the second element will come from B. So this will be 1A, 1B, 2A and 2B. Now, how how many subsets does this have? Subsets of A cross B. How many subsets will be there? So these number of subsets would be number of subsets. We already learned this is equal to 2 power number of elements in the set. In this 1, 2, 3, 4 there are 4 pairs, so 2 power 4, that is equal to 16. So there are going to be 16 subsets of this set A cross B. We are not going to list all of them, but we'll try as many as we can. So let's start writing those relations. Every set does have null set as its subset, and then R2, that is equal to first pair 1A, and then R3, which is equal to 2A. So here are all the 16 relations which are in fact subsets of A cross B. And these generally we are not required to find all the subsets, I mean all the relations, but anyway, these are all the relations from set A to set B. Similarly, if we define B cross A, we might be asked to find relations from set B to set A. If we give them a different pictorial representation, for example, if we write them in the Venn diagram, we draw two circles. One is A and another is B. And let's write down 1, 2, and A and B. And under relation R16, what is the result? 1 is related to what? A. In fact, we can also say that A is equal to R image of 1 under R16. And similarly, 2 is related to A. So this, in other words, we can say A is image of 2 under R16. Similarly, if we take a look at 1B, means 1 is related to B. Means B is image of 1 under R16, and also 2 is related to B here as well. So B is an image of 2 under R16. These notations are very helpful. We also read them that A in this case is image of 1. In this case, A is image of 2 under R16. And in this case, B is image of 1. And in this case, we say that B is image of 2.